breaks into two. What do we do? It's okay, I'm an engineer, so I'm gonna fix this for you. Take me with you.
Alright, so based on the video just now, you can see that the forearm crutch broke between members C, D, and DE. So to analyze the point of fracture, we actually have to look into the stress and strain at point D. But before we do that, of course, the first thing we have to do is draw the free body diagram. Now, as you can see in this free body diagram, there are 6 forces acting in 5 different members. Member AB, member BCD, member DE, member EF, and member FG. Now, the reason there are 5 different members is because each of these members are made of different diameters. These are the diameters and these are the lengths. These are the forces that we will assume to be acting upon each member. Alright, now that the free body diagram is settled, we can now look at the stress and strain of members BCD and DE. The first thing we look for is stress. For stress, we'll be using the formula F over A, where the force will be the sum of forces acting upon the member from the top to the member. Now that we have the stress, we can now find the strain using the formula deformation over length. But to look for the deformation, we'll have to use a different formula, which is PL over AE. P being the force, L being the length, A being the area, and E being the Young's modulus. Since our crutch is mostly made up of aluminium alloy, we can use the standard Young's modulus of aluminium alloy, which is 69 gigapascal. Alright, these are our final stress and strain of members B, C, D, and DE. With the point of fracture being at point D, you can now use the stress and strain as our reference to repair the shaft. We'll also have to know the shear stress member HI is experiencing. But obviously, the first thing we'll have to do is draw a free body diagram. This is member HI. We can now use the formula P over A to look for shear stress. We can assume force P is 50 newtons. Now to look for torque, we can assume that member HI is experiencing force P at point I. Using the formula torque equals to force times distance. But to look for the maximum shearing stress, we'll have to use the formula torque times radius over J. This final answer is the maximum amount of shearing stress that can be experienced by member HI before the shaft fractures again.